Okay, we'll get started because the stragglers will not miss any of the important stuff anyway. They'll miss some of the introductory stuff. So I'm going to share my screen. So Jason, if you could let me know that this is working when I get this up, that would be much appreciated. Is that looking good?
Look at that. Beautiful.
Sure. Welcome to our show. This is the February 2022 edition of CNCF Canada, where we discuss all things Kubernetes and cloud native. Happy New Year, everybody. We're happy to see your smiling ha-has and like emojis. We hope to see you in person sometime soon too. So we're going to do a table of contents here. We're going to do an introduction and housekeeping. Then we'll talk about some CNCF news, and then we'll move into the main event. So first, we've got Ritesh Patel from Nirmata to talk about managing Kubernetes workloads and clusters with Kyverno. And our second talk from Roy Reshef at Densify is Observability Jailbreak, rolling your own observability. We'll talk a little bit about charity and then do the super exciting prize draw. So we are your hosts for today. Jason, don't worry, I got your back. I'll fix that for you, Hattie. Alex, the humblest, kindest tech genius on the planet, Gervais. And I'm Johan. There are many other CNCF Meetup organizers. They're all super awesome human beings and good friends to have. So reach out to them, say hi on Slack. Our sponsors make these virtual meetups possible, and the real live meetups too. So we organizers are volunteers, but all the prizes, the software to prepare and host these meetups, and when we're in person, the food and beverages all cost money. So without JFrog and Elastic and our new 2022 sponsors, Microsoft and SUSE, we wouldn't be able to do this. So show them your love and appreciation for making CNCF meetups happen. A little bit about today's speakers. Ritesh Patel is the co-founder and VP of product at Nirmata. He'll be talking about Kyverno and managing Kubernetes workloads and clusters with Kyverno. And from Densify, we have Roy Reshef, the senior software architect at Densify, exploring when and why an application should provide its own metrics. A little bit of housekeeping. You can join us every month as we divide into teams and play virtual laser tag to decide whether a technology is good or bad. Last month, Prune single-handedly took on the Helm is Good team. Next month, we're going to be dividing into Web3 good versus Web3 bad teams. And so you can find out more about our laser tag on Slack. You can scan the QR code here. And you can also watch replays of our meetup videos on YouTube, and you can follow us on Twitter and LinkedIn for news about our events. We are always open for new talks. If you or someone you know has an interesting CNCF related topic to discuss or a story to tell, we would love to hear from you. So you can submit your talk proposal through paper call, or if you have questions, you can talk to the organizers and say, hey, how do I do that? Either here in chat on Bevy or in Slack. Now, we've got a quick ask, as Jason mentioned earlier, for those who are here early, we're hoping that you can fill out and submit the Observability Jailbreak questionnaire so that we can talk about the results a little bit later on. So this is specific to today's talk, Roy's talk, and so if you can get started on that anytime, you can scan the QR code here, and we'll paste the URL into Bevy. Now I'm going to turn it over to my co-hosts, and we'll talk a little bit about CNCF news.
All right, CNCF news. Let's jump right into it. Next slide. All right, KubeCon, always one of the big things of the year. So KubeCon EU is coming up May 17th to 20 in Valencia. If you haven't registered, now's the time. And as always, those recordings will be on YouTube. And mark your calendars for North America. It'll be in October in Detroit. So not in sunny California this time, but in Michigan. So Yeah, market night calendars. A little bit of change in the observability space. Open metrics becomes now incubating, and open tracing now gets archived. So a little bit of change there. But again, all part of that new ecosystem, including open telemetry. And of course, now you might have seen last KubeCon some talks with Limit Chaos, but now they're official, part of an incubating project of the CNCF. And so I encourage you to check out their project. It's kind of interesting, adding chaos engineering into the mix a little bit more formally.
Cool. Thanks very much, Jason. And now we're going to hand over the reins to Ritesh Patel from Nirmata, talking about Kyverno. So I will stop sharing my screen, Ritesh, and hand it over to you.
Thank you, Johan. Just let me know if you can see my screen, and then I can get started.
Looks good.
All right. So, hey, folks. Good morning, good afternoon, depending on where you are. I'm going to talk about Kyverno. Kyverno is an open source project that was conceived and created by Nirmata, and it's now a sandbox project in CNCF. So, a little bit of background: I'm one of the co-founders at Nirmata. Also lead products. I have experience in enterprise software, and most of my career I focused on automation and security in various domains, whether it's data center, wireless, wired networking, and now cloud native technologies. So feel free to reach out on LinkedIn or connect on LinkedIn so that we can stay in touch. So obviously, I'm not going to talk Kubernetes and what is Kubernetes to this group, assuming everybody knows about Kubernetes. And obviously Kubernetes in the last years has made significant, has gained significant traction in the enterprise, as you can see with some of the numbers. And the interesting thing is, folks adopting Kubernetes have seen quantifiable, clear benefits as their adoption of Kubernetes increases, right? And this has been steadily increasing as Kubernetes has become, more stable, more, great. Obviously, Kubernetes is a fairly complex system, and there are challenges. Kubernetes, because of its declarative way of describing resources, has a ton of configuration, and some of the challenges in Kubernetes are associated with things like misconfigurations or even in some cases not knowing what to configure to make sure your workloads are deployed securely. So this is where one of the areas that we realized what was kind of missing and could help with some of these challenges is policy management. So in Kubernetes, there have been some policies like network policies, pod security policies. In some cases, they've been pretty difficult to use. Pod security policies were, the initial implementation was deprecated, and now there is a new implementation of that. But policy management addresses some of the challenges as you adopt and scale Kubernetes, right? From handling or addressing your container images and ensuring your CI/CD pipeline you're able to secure your manifests and images as part of your build tools, as well as with cluster-wide configurations, workload configurations, and extending that to runtime scans. So the tweet here is pretty interesting. I thought it was spot on. If you think that you don't need policies in your cluster to manage or to govern how your clusters are being used, it's just a matter of time before you start seeing some of these issues, right? So that's kind of what prompted us to launch Kyverno. So Kyverno is a Kubernetes native policy engine. It helps address some of these policy management challenges. Originally, Kubernetes was conceived as part of our cloud Kubernetes management solution, but in 2019, we spun it out as a standalone component, and we built it as a Kubernetes native policy engine. So prior to Kyverno, you may have there were other policy engines, for example, Open Policy Agent, but that was not Kubernetes native, and it was built pre-Kubernetes, and then retrofitted into Kubernetes with projects like Gatekeeper. So Kyverno addresses some of these key pain points for Kubernetes admins, like blocking insecure configurations, ensuring defaults and required configuration. For example, if you need certain labels, if you need to ensure that probes are always configured, promoting best practices for the applications, and then based on these policies, there are policy violations that are reported that help developers address these issues. One thing about Kyverno is it's super easy to use and write policies for, and we'll look at that in today in the presentation, and I'll walk through some of the policies. So Kyverno, it doesn't require you to use any language or learn new language to write policies. It's predominantly just a YAML, and it's very kind of low code. It's if you're familiar with Kubernetes and Kubernetes YAMLs, the learning curve is pretty low from that perspective. A little bit about the Kubernetes, about the Kyverno community. So Kyverno became a sandbox project in 2020, late 2020. We are actually in the process of moving into incubation, and since then we've seen a significant number of downloads. It has accelerated. At this point, we are almost over 1 million downloads per month. And in the last year, we've seen the community grow, 3x, both in terms of contributors and commenters, and with a lot of different companies now starting to leverage Kyverno in their Kubernetes deployments, right? So it's seeing is as the awareness of the policy and policy management grows, platform teams and platform engineers are baking in policy management into their solutions, whether they're building on just open source or whether they're using OpenShift or any other solution that's out there. So that's something that continues to accelerate the adoption of Kubernetes. Right. So let's talk about what is Kyverno and how does it work, right? So Kyverno acts as an admission controller in your cluster. So it's a very kind of lightweight part in the cluster, and it creates and configures webhooks that are part of Kubernetes, the validating and mutating webhooks. And based on those configurations, every request that comes into the API server of Kubernetes, it gets passed into Kyverno so that the policies get applied. Now, themselves are defined as custom resources in Kubernetes. So, they're a Kubernetes native YAML, and those policies get processed by Kyverno. And as and when the come in, Kyverno, matches or finds out which policy to apply and applies the policy to the request. So, examples that will hopefully make things clear. But in general, Kyverno is a low-code policy engine, though it doesn't require learning a new language, acts as an admission controller, so can not only audit requests, but it can even deny. If you want to prevent certain configuration from being made to your cluster, you can actually deny, and it will prevent that configuration change from happening. And it can do background scans and detect other issues and configuration issues in your cluster. Now, there are also extensions of Kyverno through adapters that have been created by the community to get vulnerability scans, which are image scans, and detection with projects like Falco and others. So you can use the same policy, same reporting that Kyverno to get information about all of these different types of security kind of scans and so on. So the Kyverno policy itself is pretty straightforward. It has the structure right here. So policy contains one or more rules, and in rules have kind of two sections. The first section is it checks what this rule applies to. So you'd match some Kubernetes resources. It could be a deployment or a pod or any you could specify, even filter it to like which namespace and so on, or exclude certain resources from being from policies being ever applied to those. So for example, if you have some system namespaces, you can exclude those at per policy level. And the second section is where the action happens, right? Whether you want to validate the resource, mutate a resource, which is change that came in, for example, adding labels, generate a new resource. So actually, one of the unique things about Kyverno is it also can generate new resources. So if you, for example, when a new namespace is created, if you want to create your quotas, limits, those kind of things can be automated very easily through this generate capability. And the newer capability that has been added is to verify images. And that is super important nowadays with some of these supply chain software supply chain attacks that we are seeing with code being tampered with and things like that, right? So verifying images and ensuring only signed images are deployed to your cluster becomes super important. So that's something that Kyverno does, and I'll show an example of that. So quick example of what the policy looks like, and this is a very simple policy. It has a rule to check for labels. It applies on any pod, and what it does is it checks for a pattern. The app Kubernetes IO name label exists on the pod or not, and if that pod doesn't exist, it will. If the label doesn't exist on the pod, it will reject. Will not let the pod come up because the validation failure action is enforced. You could have an actual action to be audit, and in that case, it won't reject the request, but it will just audit and notify that. So you can run your policies in enforce mode as well as audit mode. In terms of, I briefly talked about securing the supply chain. So this is a quick flow of what that would look like with Kyverno. So you would use, whether using Jenkins or any other tool to build your images, you can use the same tool to sign your container images. In case of Kyverno, we've been using Cosign, which is a new project at Sixstore to sign these images, and then those you can also add other metadata using attestations, and this is there's a attestation format that's becoming more and more popular called Intoto, and that can be leveraged to add attestations. For example, with things like whether your images are reviewed, whether they're scanned, those kind of attestations can be added. And then you can create policies which in for Kyverno that can verify signatures and attestations at admission control and with runtime scans. So this will ensure that only signed images and only images that have the valid attestations can be deployed to your clusters. So I have a few examples here, but in the interest of time, I'm just going to jump to a quick demo. So the examples here are mainly for what the supply chain, kind of policy looks like. But I'll skip to a demo and show actually how Kyverno cluster and Kyverno is already deployed in the Kyverno namespace. And in this example, the first thing I'll do is I have a policy. So I have some policies. I'm going to show you the require labels policy that we saw in the example. And in this case, I've just changed the label to, the demo, app Kubernetes IO demo, and it will look for that label. So, once Kyverno is installed and there are CRDs that are installed for the policies, you can actually create these policies just by, applying the YAML. So here I create this policy. And so if I go look at short for cluster policies, it's going to tell me that the policy is there and it's enforced and it's ready to be used. So now I have a deployment called Nginx. I'm going to try and this deployment does not have that label. So the deployment does not have the demo label, but my policy, which was require labels, set in enforce mode, and it needs this label. So what should happen is this deployment should be rejected by Kyverno, saying that it doesn't have, right? So that's basically very simple. It's a deny rule, which denies that any resource or any resource. In this case, this rule is on a deployment, so it's going to deny any deployments that don't have this label. One example. I'm going to delete that policy and then show you another policy for image verification. This is mainly for the supply chain example I mentioned earlier. So the other policy, and I have a policy called check images over here. And so we will apply this policy. It says only allow pods with images from this repo or this signed with this key, right? So if I say kubectl create -f check images, so this should allow image get cpoll to just make sure the policy was deployed and it's ready. Now I in GitHub over here, it's just a pause image, for this example. It doesn't have any certificates or any signatures yet. So I'm going to try and run this image. So I'm just going to run this as a simple pod. And it's blocked because there was a signature mismatch. So this is, if there's any image now that's not signed, because we have a policy, this image is going to get blocked. So what I'm going to do is actually sign this image. So here I'm going to use cosign, which is part of the Sixstore project. To sign this image, I already have the key and key generated. So I'm going to sign it here. Just provide the private key, and it sign this image and push the signature to the registry. So if you see now, if I refresh, I should see right here. And now, if we go back and try to run this spot, it should run because the image matches, right? So default namespace and the image. This is these are quick examples of what Kyverno is capable of. There's several policies. If you go, Kyverno, you can learn more about Kyverno at kyverno.io. There are policies. We have 100+ policies, all kinds of policies. You can see a lot of different examples to learn and understand and even try these out depending on your requirements. And then here's the GitHub page where the project is, and if you're interested in contributing, or if you need to file issues, this is where you would do that, right? So kind of just to wrap things up, let me go back. There are some, if you're interested in learning about what is Kyverno, or how is Kyverno different from OPA, it's mainly because Kyverno is Kubernetes native and does not require a new language to learn. And this is kind of the difference between how the policies are. So in Kyverno, it's it's YAML, which is a simple policy for just read-only file system. And with OPA, it's you would have to write some Rego code to kind of do the same thing. Now, Gatekeeper and others try to address this, but of course, it's not available. You cannot do that for all the use cases. So I'm from Nirmata, so we provide solutions on top of Kyverno to kind of secure end-to-end secure your supply chain, right from build, deploy, and run. So we have a product called Policy Manager, which lets you manage Kyverno on multiple clusters. So it leverages the open source Kyverno policy engine, but then you can do policies as code, and you can get policy violations, and we are adding support CIS benchmarks and all kinds of other feature capabilities that enterprises need on top of Kyverno. So to summarize, and I think we're almost at time. So we know that Kubernetes is being rapidly adopted, but there are some gaps because Kubernetes is not secure by default, and it requires you require tools to kind of ensure that clusters are secure. Policy Engine is a great way of ensuring configuration security for clusters, and Kyverno is a policy engine that's designed for Kubernetes. So it's very easy to use. Helps you not just secure your clusters, but also helps automate common tasks with its mutate and generate capabilities. And here are some useful links if you want to learn more about Kyverno or Nirmata. You can try one of these links. Also, I can share these on the chat if needed. And yeah, we can take those right now.
Yeah, thanks, Ritesh, for the great talk. We do have some questions that came in through the Q&A tab in the chat section of Bevy. Yeah. So I'll quickly go through some of them. You mentioned Kyverno not being based on OPA and Gatekeeper. You shared your comparison matrix, and I think people are actually eager to know more about this. So if it's possible for you to share your slides afterwards, it would
absolutely
be very appreciated.
Yeah, these should be able to share these slides.
Thank you. So one question from Martin: does Kyverno run as a deployment or a daemon set?
It runs as a deployment. It's HA, right? So you would run multiple in a mission critical cluster. You want to run Kyverno in HA mode, so you would have, depending on the size of your cluster, you could have 2 or 3 pods in your deployment, and it does all of the leader election and all of that. It uses etcd to kind of figure all of that out, and doesn't need to run as a daemon set. It doesn't need to be on every node. It's just the main reason you run it as HA is because it's an admission controller. So if Kyverno goes down, it could block your request from coming in. But there are ways to actually configure the webhooks to prevent it. You can, in case of failures, if you can configure the continue processing requests in case of failures, but ideally you don't want Kyverno to fail, and you need to run it in HA mode.
Right. Good. Thank you. One question similar from Rakesh and Bruno, who want to know how does Cabernet handle new policies or updates to policies in regards to existing workloads? What happens to resources that fail a new policy?
Have the option of anytime you create a policy, you have the option of configuring the policy to run as background scans. So if it is configured, if background scanning is enabled, the Kyverno will actually check existing resources that match that policy and report violations on that, right? So let's say the policy I had for labels, if the background scan is enabled, it's going to tell me that different pods don't have this label which you required, and so they are in violation of that policy. It will not go and change or update anything in the cluster. It just reports those violations. And now what we see when folks use Kyverno and even our products is, these violations are now fed back to the application teams to address in their YAMLs, or if it's something related to the image, they would have to do it in the CI/CD pipeline, right? So Kyverno will not edit anything, but it will report those as violations.
All right, thank you. Let's go with one last question from Archie. Is it possible to create custom policies for, say, Istio? Is there something that we can? Yeah, or
absolutely.
Any custom resource definitions for objects?
Exactly. And I think I went through it very quickly, but if you go to the Kyverno.io site and examples, we have custom policies for Cert Manager, which is another CNCF sandbox project, right? So in theory, you can create policies for any resource, custom resources, right? So Istio, Cert Manager, Knative even. I mean, again, and we are seeing more and more use cases emerge. We are working with companies that are doing data protection, working with on the cost side, right, related to cost. So any custom resources, you can create policies. And the other pattern, there are some other patterns emerging. If you want to create policies based on data that's outside your cluster, you can write helpers which can bring that data into your cluster, put it in a config map, and you can create policies based on that as well. Cost is a very good example for that.
Perfect. Thank you a lot for your presentation, Ritesh. There are more questions in the Q&A tab if you have a few minutes to spare and maybe answer by text. Otherwise, Johan, want to introduce Roy?
Awesome. Thank you very much, Ritesh. Yeah, definitely a popular topic there. So I'm going to move along here to a very brief slide. Introduce, if I can get into slideshow mode. There we go. So next up, we have Roy Reshef, Senior Software Architect at Densify. And we're going to talk about when and why your apps should provide their own metrics. And so after that one slide, I'm going to hand over the reins to you, Roy, and you can take it away.
Okay. I hope you can all see my screen and my feed properly. Thank you. Okay, let's jump right away. First of all, thanks a lot for everyone that filled in my very short observability questionnaire. I know it's probably not statistically representative in any way or form, but it's always good to get feedback from the community and to see who people are, what people are doing. If this would have been an in-person presentation, I would just ask you to raise your hands. That's not exactly possible. That's why I did it this way. Let's jump to the presentation. I have to warn you that I got a bit of a cough. I hope I won't cough in your ears too much. And I don't know if it allows me to use full screen mode, but let's go with this, and hopefully you can see my slides properly. I call this presentation Observability Jailbreak, and it involves things that I've been doing for the last couple of years when I noticed that the standard observability concepts and tools don't always cut it. Another term is application-aware observability, namely observability which is based on what the application knows and does. A bit about myself. My background started in QA, then development and software architecture. That's why I asked people what their role or background is. I had a feeling that the vast majority of the attendees of these presentations come from DevOps / SRE / cloud architecture background. I saw it's about 60%, and there are about 30% with a background similar to mine. I've been around for a number of decades. Let's say that N is an uneven prime. I'll let you figure that out. Out of all of these decades, the last 3 years, I've been with Densify. Now, for those of you who don't know, a very quick overview of Densify. It's a Markham, Ontario, in the GTA-based company. It exists for 2+ decades. And what our systems do is they provide our customers a way to optimize their resources. And when it started, it was, of course, physical data centers. Then it moved to virtual data centers, then to cloud, and to containers. I'm not going to talk about Densify products. I'm not trying to sell these to you. I'll just show you how, when we went in our containerization and orchestration journey, which when I joined Densify 3 years ago, it was just starting, how we were dealing with observability and how our application and our chosen architecture needed to accommodate to observability tools and concepts. My focus, I do application and software architecture. I'm a hands-on architect. I code quite a bit. I focus on cloud native, containerization and orchestration and observability. The language that I'm dealing with the last couple of years are mainly Go and the different variants of Shell. But if any one of you recalls when JDK 0.9 was released, hint, it was the mid-90s. That's the first JDK that I laid my hands on. So I was a good number of decades in Java, the Java sphere. That's a question that I was once asked in a job interview. What is your professional creed? So not personal creed, like not what you believe in personally or religiously, but professionally. I have a few guidelines. Usually try to write less. I mean, software system gets very bloated. If you can reuse something, especially if it's open source, then clone it rather than build it. In the pre-open source software era, it was buy rather than build. The bootcamp software, it's not bootcamp, but this quote is from military bootcamp. I grew up in Israel where people had to go to the army. And one thing that you would hear from the commanders when they were telling the new recruits, trying to motivate them, is, if I translate it freely, there is no cannot, there's only I don't want to. And I'm not going to speak about building software as a military paradigm, but this I mean, this meme or this sentence applies to a good number of nines of what we do in software. I'm yet to see the case when I have to, implement some things that is technologically not feasible. Well, I'm not trying to break elliptic curve cryptography algorithm for the NSA. Maybe that is, but pretty much everything that we want to do, we need to do, is doable. Whether we want to do it or not, it's a different story. And the last point, and that leads into our topic, is what I call environment-aware applications, namely applications that are aware of what's available in their production environment and they use them. And the reason for that is that awareness is collaboration. In the case of the observability, it's collaboration between the owner of the production environment, which is typically a DevOps organization, and the application architect or developer. Now, this is unfortunately not the approach of many organizations, including, I even heard from some folks that works for tech giants. Some organizations, I hope there are less and less of these, but they are trying to shield their devs and their architects from the production environment. Now, when I'm talking about apps that knows an environment, if I would tell you, hey, my app is using a file system or network stack, you will probably laugh because that's nothing special, but that's part of the operating system environment that the app is running on. Nobody will raise an eyebrow if I tell them that my app is using all kind of software infrastructure components, like, data sources, message brokers, and the like. That seems very normal and natural. And my question is, why shouldn't my app know and make use of the fact that it is running on cloud native, in a cloud native environment? It starts with container runtime. The classical example is the logs, that if you run natively or on a VM, you log to a file or to std out. If your application is running a container, that's not good enough because you have to write to the std out of process number one. Otherwise, whichever environment you're using, Docker or Kubernetes or whatever else, will not be able to scrape your logs. Another example is, do I care? And I do. If my application is running as a pod and Istio is enabled for my pod. And that's a twofold because whoever of you who is familiar with Istio, and we're using Istio in our production environments for already 2+ years, it injects a sidecar, which is called Istio proxy, which takes care of the entire network stack of the pod, ingress and egress. Now, Istio proxy, unfortunately, needs sometimes to start up. It needs to connect to the Istio headquarters, let's call it. That has changed through the versions of Istio. And it takes some time. I even saw examples when it can take a good number of seconds. What you see in a lot of applications that upon startup, they are reaching for all kinds of resources on the network and are trying to communicate with them. And if they don't, they either go into a retry mechanism or sometimes they even fail and they say, hey, I need my database, I cannot reach it, I'm bailing out. If you're not aware that you have Istio proxy in your environment, you're going to bail out in this case. And so that's one reason. Another reason is if your pod is running as a short-term pod, let's say you're running it as a job or a Kubernetes cron job, it needs at a certain point to exit. It's not a long living, let's say, part of replica set or deployment or whatever. If you're running a Kubernetes cron job with Istio and you try to exit, guess what? Your main container will exit, but Istio proxy will hold your pod alive forever, practically. So you need to know that. Another example is Prometheus. And that's another question that I asked, do your own apps provide their Prometheus exporter, and we can see that the vast majority of the people who answered replied positively or they want to do it, which is good. But this, of course, only means anything if Prometheus is part of your environment. If Prometheus is not part of your environment, then what's the point? Now, I've been looking into observability for quite a few years, let's put it this way, and I see that there are two approaches. The most common one is what I call application unaware approach. Most observability concepts and tools that we have, they don't really care what the app does. They don't really look into it. They just, let's say, either collect metrics or some other or observe some other things which have to do with, standard standard metrics like CPU, memory, network throughput, disk throughput, whatever else. And there's a long list of the tools that we are using that this is our approach. They do not know what your application does, and the application cannot even tell them, hey, I'm doing something now in a specific context. When you see the application aware approach, you mainly see it in OTel, OpenTelemetry. And for example, the concept of span that I believe started with Jaeger, then moved to open tracing, and now it's part of OpenTelemetry. Span is something which is either it's a scope or a context which either one app defined, or it could be even cross app if you have microservices calling each other. It could be a request. It could denote the relevant user, or in the tenant if you're having a multi-tenant application, and so on and so forth. Why do we need more application aware observability? Because, and that's something that we have seen in Densify, the standard unaware tools, or tools that are not aware of what your application is doing, quite often they fall short. And awareness is also a collaboration. If I, as an application architect or developer, provides observability tools to my DevOps guys, then they can do their better job on the observability front. Otherwise, they're on their own, pretty much. Now, after this introduction, sorry if it was a bit long, let's look at a very typical and rather simple service. And trust me, there are millions of services and microservices that works this way. I mean, this pattern is so common, it's almost trivial. So our service gets a request from the outside world. It may need to do some initial validation, and then it needs to go and read. And I was using here different terminologies. I mean, you won't use pull or fetch because nobody uses Git, but you may use REST API and do a GET request, or you may use, if the party that you are talking to is not another service, but your data source, let's say an SQL data source, you can do a select query. And there are different ways to do it depending on the technology, but you need to bring over data. So you ask your party, which again, your party may be another microservice that asks another one, and so on and so forth. So this could be a chain, but you need to gather some data. So you gather it, and eventually you get a response with that data. Then you have some phase of computation, and you may do further validation, or you may need to do some data processing, ETL, depending on whatever your business logic is. And after you're done with that, often you need to write some data off. And again, in Git terminology is push, but you don't do it with Git. In REST terminology, it's a post request or a put or a patch or a delete. In SQL, it's insert, update, or delete. I mean, you get my point. And you may do it either with the same service or data source, or with another. Doesn't really matter. You need to write off this data. So you send another request to do that, and then you get a response. And eventually, you can tell your caller, hey, I'm done, and give them a response for the initial request. Now we have, and that's an example, that real-life example that we have at Densify. We have a very similar, although slightly more complex example, where that a whole sequence of read data, compute it or process it, and write it is iterative. So once we get the initial request, we need to do some iterations, and lengthy too. But that's the only difference between these two. Now let's think about scalability, namely HPA, and how we can scale these pods, how we may want to do it. So at each one of these, and some of these, the read and write action, I also split into phases. Let's look at the workload profile of each one of these events or phases, and which one we can use actually as a good metrics for HPA. So overall is an initial request that we get. Originally, we get a request. It starts with a 1+ means a small or a negligible quantity or throughput. 3+ is a large one, and a question mark is when it's very variable or we cannot know. So a request starts with a small amount of network data that comes in. It doesn't require a lot of CPU. It doesn't require a lot of memory either. Also, the initial validation, because it's based on that, is pretty much the same. And the duration of these events is pretty small. Now, when we need to do our read or pull or fetch or get or whatever we do, we often send out a small request. When we send a read, requests are typically rather small. I mean, think about, for example, an SQL select query. They are usually not that large. There could be a few Ks if it's a really complex one, but they're not very big. So we have, again, a bit of CPU usage, a bit of memory usage, and a small network out event. By the way, the disk columns are here just for completers. I hope that nobody does persistent with disk, but you can if you want to. So, okay, we sent the read request, and now comes a latency, and the latency is a huge question mark. We actually do not know. We depend on our data source, or we may be depending on other services that are working. There could be so many dependencies here that it is really a question mark. Now, when we get the response to our read request, whichever it is, typically we get quite a bit of data back. And so the network in event is rather large, or the throughput. The memory we need to allocate for it is rather large. We don't require a lot of CPU, and it doesn't take that long to pick up stuff from the network stack. Now we have the compute. That's usually when we are hammering the CPU, and we may need to allocate more memory. And the duration of that is, this is anybody's guess. It's really variable. When we write data, we typically send off a lot of data. So we use quite a bit of memory. We send it off. It doesn't take a lot of CPU. And again, the latency of this, depending on what happens in that data stream or directly data source, is very variable. The response that we get, it depends if we get back. When you write data, sometimes you get back what you wrote, sometimes you don't. So it could be variable. It typically is not. Typically, it is small. And then if we get back to the overall phase that the request started at the beginning, again, the latency is rather large, or could be large, or maybe is unknown. And the response that we send back is usually pretty small too. Now, if you look at this, especially if you're working in an iteration, if anyone can please tell me, what should I use here as metrics for scaling? So our first attempt, we try with standard metrics of HPA. As I said, latencies could be quite significant, and the process is iterative. So they both amplify the problematics of using CPU, and CPU turned out to be quite a bad indication, as the pod can be actually very busy, but it is waiting on its data stream, either a service or the data source, to respond, and then it is not doing much. Same thing with memory. Once we send the read or the write request, we may be very busy, but we are waiting. And maybe we released memory already because we don't need it anymore. And now you have to take into account the runtime garbage collection if you're dealing with Java or Go. So these turn out to be not good indicators for HPA for us. And if your HPA is not fine-tuned, I'm pretty sure you guys, your DevOps guys have seen it, it can have a negative impact on your performance. There's no way to tell it to exactly which pods to evict. And if you have an iterative, lengthy process, you can have bad luck, and HPA can evict a pod which has already been, in our case, it was even for hours, and firing off requests and waiting for them for long, and requests are close to being completed, but yeah, HPA picks it by random and just kills it. What you can have with HPA is that if it scales up and down too aggressively, you are wasting too much resources on autoscaling. And HPA is meaningless without a cluster autoscaler, because if you are scaling more pods, you may need more nodes. So this can have an impact not only on that specific pod, but on the entire cluster. And this Grafana dashboard shows what I dubbed neurotic HPA. This is when we configured HPA, misconfigured it to use CPU. And we have this service had actually every 15 minutes, some cron job would wake up and run some queries and fire work to this pod. And the amount of work is roughly the same each and every time, or was, at least in this time span. But what you can see is that we scaled up and down, and we went, I think, all the way up to 30 and down to 5, and the average was 15. And this is not good. So, I mean, our turning point was, and I still remember the date, because if you don't remember, week 11 of 2020 was the second week of March. That was the last week that I've seen my colleagues in the office. But the last week we've been in the office. We've been remote since. And then my colleague Ian, he's a senior developer in my team. When we saw that we had HPA issues with the CPU metrics, he said, hey, can't we actually use our own metrics? Because HPA supports custom metrics. So credits to Ian for pointing us out in this direction. And so what kind of custom metrics we can do, and maybe the number of tasks or jobs that we're using, or the weight, because not all tasks are born the same. Maybe you want to consider the weight of the tasks. It took us, believe it or not, about a week to implement it. That is all. And our DevOps guys, they changed the HPA configuration to use custom metrics. And as you can see, this specific pod or this specific deployment is scaling massively from 3 pods at leisure time to up to 150 pods when it is busy. And we also put our HPA rules to downscale only when the number of jobs is going down to 0. It may be a bit wasteful, but you're making sure you're not having the scenario when you are evicting a pod that has been busy already for a long time. And this mechanism has been working side by side with EKS. This was deployed in EKS with the EKS cluster autoscaler like magic since, and I'm talking about 2 years roughly. And this is how it looks like. This is our custom metrics. And you can see there are here, I think, about 50 pods that participate, and they all contribute, and each one of them telling. And this goes over, I believe, a good number of days, and how many jobs these pods were handling. And this is what we based our custom metrics on. Now you may say, oh, but implementing our own custom metrics might be very labor intensive. Can I, as a DevOps guy, ask or even demand my dev organization to provide it? And my answer is, if you know EPLS acronym, easy peasy lemon squeezy. And I think you can. And if your devs tell you it's too much work, you can send them to me and I will tell them how and why it is not. And I'll show you quick examples. I see I'm getting a bit over time. With both Java and Go, the first ones that we did was with Java. Java has a concept of JMX mbins, which are managed objects for monitoring purposes already for roughly 2 decades, I think even more. And you have a simple API to register mbins if you want to delete them and to query them. And you don't need to update an API to update them because mbins are your Java objects. You can do whatever you want with them. The JVM itself manages a ton of mbins of interest for monitoring. For example, CPU, internal memory, Java memory model is very complex, garbage collection metrics, and who knows what. Now, the guys from Prometheus, they have an official JMX exporter, which had its first release, I searched it out, in 2015 already. You can configure it. You can run it as a Java agent, and a Java agent is something that you would like because it means that your application doesn't need to deal with Prometheus at all. All it needs is to register and maintain its own mbins for monitoring purposes, and that's it. And the exporter will do everything else for you. And my recommendation is that if you don't use the JMX exporter for your Java app, use it even if you have no custom metrics. And I'll show you very briefly how this looks like. So this is a, there's really hundreds of metrics here, GC collection metrics, and all kind of memory pool metrics, and threads and processes, and so on and so forth. There's a plethora of things, and this completes a picture like from the inside of the JVM, which is running in your pod. I mean, CAdvisor gives you what the pod knows or the container runtime knows about the memory and the CPU, how you use them from the outside. Now, with Go, it's similar, although Go executables are native binaries. There are no VMs. So you cannot use agent approach. But the Prometheus Go client makes it very easy to register metrics and to run an exporter. And by default, similar, the Go client exposes a lot of runtime. Let me find one of these. This one, Go memstats, Go routines, Go GC duration, you name it. These are all exposed by default by the client. And again, my recommendation to you is that if you have a Go application, even if you have no custom metrics, use you need to do a bit more dev work because you need to run the exporter handler and to register your metrics, but it's really a piece of cake. A few guidelines to both of these. When you are providing your own metrics, you have to think about thread safety. The Go client metrics, Prometheus Go client, are Go routine safe, so you have no issues here, but Java mbins are your objects, so you have to make sure that they're thread safe. We also identify between 2 kinds of metrics, the ones that are updated real-time and the one which are polled. Now, real-time metrics is the one that the application updates whenever something happens. The application does something, it raises a counter, or in our case, a number of running jobs, which is a gauge. It needs to set it. So these things happens regardless of someone is asking for these metrics or not. However, sometimes you cannot use real-time metrics, or it might be too expensive. You don't want for observability purposes also to overload your system. In this case, you can have a polled approach. Now, with a Go client, we used an approach of HTTP middleware, namely that you have a middleware that wraps a handler that wraps another handler. And there's a link. I mean, I won't go there due to lack of time, but it's not a pattern that we invented. It's available out there on the web. So what we do is that when we registered polled metrics, we register them, and we register also a function how to collect them. And when our exporter is being scraped by Prometheus or by whoever hits the exporter endpoint, only then we go and collect these metrics. Now, with JMX exporter, that's not applicable because the exporter is running as an agent, so the application has no clue when it's being scraped. So you can use scheduled polling like every, 15 seconds, 30 seconds, whatever time that makes sense. Now I'll go, and I'll do it a bit short because I see I'm running out of time, into when do you have to use external metrics. And I could see that some people are using one of the questions that I asked here is your organization using HPA, and with which kind of metrics? And to my surprise, there were quite a few people. I know I'm one of them, and Jason is another. I don't know who the other two are, but are using custom and or external metrics. The typical architecture pattern that people use in software is a service pattern. And there were different names for it, but eventually they all boil down to the same thing. It was called first back in the 1970s client server. Then in the early 2000s, we had service-oriented architecture, from which microservices emerged. In principle, in all of these cases, we have someone who makes a call and someone who is being called, or the callee. So these are two participants. It's typically a synchronous request response pattern. And our caller needs to do quite a bit of thinking. First of all, it depends on the callee's availability and performance. Also API version, but that's a different thing. That's compatibility. But so if the callee is slow or it's not available, the caller needs to deal with it. Another thing is that the caller needs to deal with errors, both errors that the callee detects and all kind of network errors. Now, most of the Kubernetes concepts and tools that we have apply to this architectural pattern. If you're looking at Kubernetes service, object, ingress, the readiness probe of a container, that's all what it means. I am ready to receive traffic. I'm ready to be a callee in this case. Now, other patterns that exist already for a number of decades is message-based patterns. And I will talk here mainly about reliable messaging. I mean, you also have streams. You also have ad hoc pub/sub. In reliable messaging, we have a producer and a consumer. A producer produces or publishes a message. A consumer consumes it. And in between, you have a broker, which is an infrastructure component. And the producer and the consumer rely only on the broker. So the producer only needs it to publish something, and it pushes a message there. The consumer establishes a long-term relationship with a broker. When it registers to consume, they have a whole protocol with heartbeats and whatnot. And then when the broker gets a message to the appropriate queue, it pushes it to the consumer. So this is typically asynchronous messaging. There are other types like streams and ad hoc pub/sub and the like, but I will not go into that because, I mean, reliable messaging is something that you typically want if you don't want to have a caller and callee or a service architecture, but you still want to make sure. A lot of cases, your caller just want to make sure that their call is being received by the callee and being handled. They don't really care what is done with it as long as it's being handled. That's where reliable messaging fits perfectly. And we introduced and densify with new microservices. RabbitMQ, that was our choice. I personally have experience with this broker for over a decade now. So we have here in our architecture, and that's a bit simplified, we have two Kubernetes cron jobs that are only producing messages. They trigger stuff. So producer A sends a message, publishes a message, which is consumed by consumer A, and similarly producer B and consumer B. Both consumer A and consumer B, they do their work, and then they publish messages that goes to consumer C, which is only a consumer. So these are publishers and consumers, these two guys, A, B, and B, and C is consumer only. Now, I'm talking about, okay, what does this have to do with observability? And the questions that I present here are only relevant to long-living pods like deployments, not to the cron jobs, because cron jobs, they wake up, they do the work, and then they exit. Now, to start with, consumers identify them with RabbitMQ, in our case, with a consumer tag. And our choice was, it's another case of an application that is aware of its environment, is to use the pod name as a consumer tag. So the pod knows that it runs as a pod, it can grab the pod name, it's being fed it, and these are standard Kubernetes downwards API mechanisms, and this is a consumer tag. Now, an interesting question I also asked, I saw that the majority of people use liveness and readiness probes, and very few use startup probes. What does a liveness probe mean for a producer? And it actually doesn't mean much, because producer only needs a broker when it needs to publish. It doesn't even need it continuously. For the consumer, the connectivity to our message broker actually means liveness, because if the connectivity is broken, I'm not consuming. I'm only being fed by RabbitMQ, I as a consumer, so nothing happens. What does readiness probe mean? That's another interesting question. It actually doesn't mean anything, because the pod is not being called. The message push is part of the protocol of the broker. In the case of RabbitMQ, it's called AMQP. So Kubernetes is actually blind to it. And now we have another question. How do we auto-scale these consumers? We could go by number of messages, but that's something that we can limit. We can limit a RabbitMQ consumer only to consume concurrently an X amount of messages. And the scalability should actually not be driven by something as a pod reports. It should be driven by the RabbitMQ status, or by the queue in RabbitMQ status.
Roy, I'm sorry,
Yeah.
I'm going to have to interrupt there. We're at time at this point, but thank you so much for your presentation. Would it be possible maybe to get a link to the slides, and then we can share?
I can publish the slides. Yeah, give me just 30 seconds, and I'll go through.
Unfortunately, our hosts actually have to leave, so we have to cut it like a hard stop right here. So my apologies for that. But yeah, if you can maybe on Slack afterwards send us a link to the slides, then we can share that with everybody, and everybody else can finish up.
Yeah, I can. Sorry, I noticed that I was running it about time. I didn't know we had a hard stop. So
well, it's just because of our hosts have meetings to get to as well. So, and personally, I've got an interview to get to. So, but thank you so much, Roy. We really appreciate everything. Folks, take a look at the chat channel to fill out the survey for this week, and we're going to do the prize draw after offline. So thank you very much, everybody. We really appreciate presentations, and hope everybody has a great rest of your day, and we'll see you on Slack.